Good evening, everyone. Hello, everyone. Good evening.
Evening.
Good evening. How are you all?
Yeah, I'm doing fine. What about you?
Yeah, I'm good. I'm good. How's the preparation going on?
Yeah, it's going on, but we are facing difficulties on maths. So like most of the times we are focusing for the maths, and apart from the others, we supposed to be doing.
Oh, maths. Okay, stats is fine.
Yeah, status okay. Thanks, thanks.
Uh, What about others? What's happening? No one wants to speak. What happened? Is it
Preparation
too
is
difficult
going
to
well.
speak? Huh? Sorry?
Hello. I said the preparation is going well.
Hmm. Okay.
Practicing PYQs and
Okay.
uh, in
That's good.
every subject and mock
Hmm.
solving
Okay. Yeah, that's going good
and
then.
revising the previous things also.
Yeah, nice. Okay. So,
Hi.
hmm. Hello.
Uh, um, I wanted to ask one like
Ah.
so if I do practice previous year questions, so most of the question will come based on the previous year question, yeah, like graded as assignment, yeah, like practice assignment.
So see, if you have done the activity questions, the graded assignment, and the practice question, so you will be able to solve, like you will be able to solve the question paper. See, what questions we are making is based on the concept. Okay, if you know the concept very well, it will be easy for you to understand the questions and do the questions. Okay, it's not a very rocket science or something. It's just a simple stats that you have already learned in, I guess, 12th class or something, correct? 11th and 12th class or
Yeah.
10th class. Yeah, so it's simple as that. Just don't make it just don't think too much about it. Just relax and chill and just read the question carefully, what they are saying, understand it and solve it. That's it. In stats one from week 1 to 4, I don't think so. It's a very difficult topic because we have already learned all about it, the mean, the median, the mode, and
Hmm.
the
Yes,
correlation, variance. They are just a simple topics, correct?
Yeah.
yes, ma'am.
Yeah. So it's not a big thing. Yeah. Main thing when it's come is in week not 5 6 5 6 7 8 from 9 to 12 it will be little difficult, like it will be little difficult, not that difficult, but yeah, it will be a new topic for you to understand till week 6 7 8, till week 8 it will be fine, like you know everything, but from 9 to
Ma'am,
12 it will be like a new topic.
till that
Actually,
conditional probability, right?
actually, the
Aha,
more we forward, the more I forget the earlier things. So that is the main things that I'm facing
what
actually.
you can do is, see, what you can do is you can just go through the, see, we have this revision session and all na. So when we have this revision session, so what the instructor, I don't know about the other instructor, but what I do is I just go through all the formulas, or I just go through all the topics that there are there in the week, in week 3 and week 4. Okay, then what I'll do, I have some 4 5 6 questions from the previous year and we will solve that. So that is what I'm going to do in this revision session. So in this week 3, like what I'm going to write, I will write all the things that are there, like a quick summary of week 3. And I will also give a quick summary for week 4. So from that, you can just see the formulas and the concept. That's it. So I guess that will be easy for you to brush up all the things, right?
Yeah.
Or what you can do is you can just make notes, like simple notes. See, from week 1 to 4, it's simple. From week 1, you don't have to make any notes. Like it's a literally like what do you say that what do you call that? Concept wise, or you can say only theoretical type, right? But from week 2 to 4 it's like little formula based, but the formula is basically that you have already learned. From 5 and 6 it's permutation and combination that you have already done in 10th class or 11th and 12th class, right? From 6 5 6 and 7 8 the probability, and also these type of things you have already learned it. So you don't have to, like, like if you want to write it you can have notes and all. If you don't, like, it's just a simple topics. Okay.
So, like, I feel that it would have been better if there was one exam per day. So, but
Sorry.
like, it would be like it would really better. It would be better if the exam has been scheduled for a per one day and each subject. So,
Oh, okay. Yeah, that's what. Yeah, I know that, but what can we do? We can't do anything about it. Yeah. So, okay, that's fine. So that's why we are having MCQ and MSQ based questions now. Uh, like if you really go to the any university or campus based, like offline thing now, if you take classes offline and all, we had our exams one day. We had two subjects in one day, and it was not at all MCQ or MSQ. It was all theory basis. So it was like 10 marks each questions. We have to write it. So it's better you have at least MCQ and MSQ based questions. That is
Ma'am,
good.
ma'am,
it's kind of a competitive exam type, like MCQ course.
Uh-huh.
So
But
Am I
it's not even the
audible, ma'am?
questions are not that difficult in the question paper. So it's I don't think so it's that difficult. Oh, I don't know about the other subjects, but yeah, I know about the stat subject. I can say that it's not that difficult. It's literally concept wise. I can say that.
Am I audible, ma'am?
stats is far better than maths. Maths is,
Yeah.
I think, tricky.
Yeah, it depends upon person to person.
Uh,
Am I audible, ma'am?
Yes, you're audible.
Uh, Ma'am, I think uh, it is good that multiple subjects exam are conducted in one day. I mean, it is pretty much doable. As I'm
Mm.
foundation level student and I have completed maths one, uh,
Mm.
so it is pretty much doable.
Yeah,
If
see, it depends upon, see, there are different kinds of people, right? So every people have a different kind of mindset and they have their own opinion. Correct. So it depends. So it's not that. So that's why we have to make sure that the question paper that we are making is that everybody is able to do it. Like
yes,
it should
ma'am.
not be a burden or something. But we also have to make sure that it's the question paper also are like they are not that easy that everybody will be able to do it. We have to make some, consistency, or you can say the like what we have taught and all that. We should also know that yeah, students know these topics. We also have to
Yes,
make sure that correct.
yes, ma'am. If we revise every topic and attend every sessions, I think it's pretty much
Hmm. Correct. Okay, so it's already 6:15. We talked a lot. Let's start with the session, shall we? Okay, I'll just go through the topics. Okay, for week 3 and week 4, and then we will do. I guess, six questions I have. We will solve that questions, and we will wind up with the session. Is that fine?
yes,
Okay,
ma'am.
let's complete it.
Ma'am, please,
Yeah,
can we today practice previous year questions?
yeah. The questions that we will do is from the previous year questions only. Like I have 6 questions. They are from the previous year only.
Okay, ma'am. Okay, ma'am. Thank you.
Yeah. Okay, so the first thing is week 3. What we are learning about in what we are learning about in week 3? Anyone?
Association between categorical variables.
Uh,
Oh, sorry, it
Between
is
numerical.
between. So we are actually describing the numerical variables.
So the histogram,
Two
stem,
types
leaf,
of
plot.
yes,
so we are actually describing about the numerical things, right?
Hmm.
Numerical data. So the first
Mean
thing that
and
comes,
mean,
so the first thing that comes up is frequency table, correct?
Hmm.
yes,
Okay. What is a frequency table? If we have, let's suppose if we have a discrete data, okay, if we have a discrete data, then frequency table discrete data in the sense if I have like 1 1 2 comma 2 comma 3 something kind of like this. Okay, so discrete data is in such a way that we make that we have some values. It's a table, we have some values, then we have some tally mark. Okay, tally mark, and then we have some
frequency.
frequency. Okay, so this is what a frequency table look like. So value in the sense, what are the distinct values? We have 1, we have 2, we have 3, right? Tally mark in the sense like how many times 1 is coming, how many times 2 is coming, how many times 3 is coming. So like 1 2 1 2 1 2 something kind of like this, and we will write the frequency here, which is like 2 2 2. Okay, so this is what a frequency table. Frequency table, we are just tallying out. We are just writing out how many times a number is occurring. That is what my frequency table is. Okay, so this is about the discrete data. So if I have a continuous data, what I will be writing? I will be writing in a continuous manner. We will be having intervals, right? Interval in the sense we have a class limit, we have same tally mark, and we have the frequency as well. Okay, so class interval and tally mark. So in the sense, let's suppose I have a data from like 30 to like it's going on till 100. So I will be having class intervals. That means my data from 30 to 40, 40 to 50, 50 to 60, and so on like this. Then I will be having some tally marks here. Okay, that the frequency is 30 to 40 in the sense the numbers that are there, which is 30, 31, 32 till 39. 40 will not be included in this. 40 will be included in the second limit. Correct? Similarly, in the 40 to 50, 40 will be included, but 50 will not be included. Similarly, in third interval, 50 will be included, but 60 will be excluded. Okay. Now, similarly, here we will be writing all the frequencies. Okay. So this is how we make a frequency table for a discrete and a continuous data. Is that clear?
yes, ma'am.
Okay.
Yes, ma'am.
Then we have one more thing which is known as a stem leaf diagram. Do you guys remember this thing?
Yes, ma'am.
Yes, ma'am.
Yes,
What is
ma'am.
this stem leaf diagram? Stem leaf diagram is basically we are just writing, like, see, what in the exam what we have a data in this form, correct, in this form there, or they will write it in this form, but we have a figure, a diagram in which the data can be represented in a stem and leaf plot, in the sense that this is my stem and this is my leaf. Okay, so that means there are numbers like 7, 5. Okay, then we have 7, we have 8, 5 comma 8. So this actually is representing that the data that I'm having is 75, 85, and 88, right?
In the ascending.
Yeah. So we are just representing a data with a diagram which is known as a stem and leaf diagram. So stem is basically my the leftmost number, and my left leaf is basically my rightmost number. That's it. Okay,
Ma'am,
is that clear?
stem is like all the numbers except the right most, right? Except the unit place digit.
Ah, correct.
If we
So
have three
hmm,
digit, then
3 digit is, let's suppose if I have 851, then my stem will be 85 and my leaf will be 1.
yes, ma'am. Yes.
Okay, we can have, yeah, so it depends upon the, like, how you're representing it. Some of them what they do is the 8 will be my stem and 51 will be my leaf. So it depends upon, so you have to, you have to tell it, or you have to describe it, that how I am dividing a data, a number, into stem and leaf. So if you remember, if you see in the questions, they already tell you that 7 divided by 5 will represent that it's 75, or they will say, let you know that 85 slash 1 will represent as 851. So they will be telling you how they are dividing the data into stem and leaf, which part
Yes,
belongs
ma'am.
to stem
It's
and which part belongs to,
written
yeah, it will be written.
syllabus.
Okay, is this thing clear?
Yes, ma'am.
Okay.
Yes.
Then next come is the descriptive measures. What are the descriptive measures? We are the like the measures that can summarize a data set. That is known as the, so we have to summarize the data. We have to numerically summarize the data. So we have a lot of data, right? So in that we have to numerically summarize the data. How will we numerically summarize the data? So for that we have some descriptive measures. So one thing is, first descriptive measure is the measure of central tendency. Okay, what is the measure of central tendency? That the measure which tells me about the center of the data. Correct?
Yes, ma'am.
Yes.
Center
In
most
the measure
typical.
of yeah. So in the measure of central tendency, the one thing that comes up is mean.
Mean.
Correct? The most important central tendency for a numerical data is my mean. Okay, what is mean? Mean is actually my average of a data set. And what is the formula of the average? It is summation of xi divided by n. Summation of xi is like what all datas I have, I will add them and divide by number of datas I have. Okay, that is my average. And if suppose if I have like a continuous data, then my summation will be what? Summation of xi into fi divided by summation of fi. This is the formula of a mean. Okay, and most important properties of mean that is that the first property is that if I add a constant, okay, if I add a constant, then my new mean will be equal to the old mean plus the constant. Similarly, if I multiply a constant, then my the new mean will be equal to the old mean multiplied by that constant. Is that clear?
Yes, ma'am.
Yes or no?
Ma'am, and also it's sensitive to out.
Sorry.
Said
Sensitive
that
to
it's sensitive
outliers.
to out.
Yeah, and the third property, yeah, it's sensitive to outliers. Yeah, this comes after we study about the median. Okay, after we study about the median, then only we will get to know that, yeah, it's like sensitive to outliers. Okay, then we have median. What is the median? Median is actually my middle value. Correct? The middle value of the
Yes.
data set. So there are two points that you have to remember. The first point is if my observation is odd. If my observation is odd, then the middle part will be equal to n plus 1 by 2. And the second thing is if it is even, then my middle part will be, the middle value or the median will be the average of n by 2th and n by 2th plus 1th value. Or you can say the observation. Correct? And this is least affected by the outliers.
Ma'am, it
Yes.
is completely not affected, right, by outliers.
Yeah, it is not that completely, but means we can say, see, no data is being the measure of, see, the median, the mode. See, if we compare median and mean, median is least affected, like compared to mean, it is least affected by the outliers. We can talk about that. We can't say that it is completely it can be affected by the outliers. We don't know, like
Ma'am,
sometimes
outliers
what we say
are
is that keep like if you have, like in general case, like practically what we have, if I have a lot of data, what we do is we actually remove the outliers sometimes. Okay, so we have that type of condition, so we usually say that it's a, or yeah, we can say that it's a least affected, or like it is not at all affected by the outliers, but normally we say that it is least affected by the outliers. Okay,
okay.
then yeah, same thing only, this here also, if I add a constant, what will happen, my old median will be, new median will be old median plus c. Then if I multiply a constant, then the old median will be multiplied by the constant. Okay, so these are some properties. Now the third part is the mode. What is my mode?
Most
The
typical
highest
value.
frequency.
Which is having the highest frequency, you can say, simple, in simple terms, which is having the highest frequency. Okay, so how many times it is occurring, so same it goes for this. If we add a constant, okay, then the old mode will be like added with the constant. Then if we multiply, same, the old mode will be multiplied by c. Fine, till here it's fine. So this was all about the measure of central tendency. Okay, then the second things, somebody was saying something. Somebody was saying something. No. Okay, so we studied about the central tendency. That means we are talking about the central point of the data set. Okay, now if we are talking about the central point of the data set, we actually don't know about the whole data set, right? We can have like two different types of data sets. Like let's suppose I have 3 comma 3 comma 3 comma 3, something kind of like this, and I can have a data sets like 1 2 3 4 and 5. So by the measure of central tendency, I'm just pointing out at one number, right? But from the with that one number, I'm not able to study about the data. Okay, so that's why we have another measure of a descriptive measure, which is known as the measure of dispersion. So what is a measure of dispersion? Measure of dispersion is actually indicating about the amount of variation or the spread in a data set. Correct?
Yes, ma'am.
Yes or no?
Yes, ma'am.
Yeah. So in this measure of dispersion, we have few things. So the first thing is we have a range. What is a range? Range is the
Difference
difference
between the
between
maximum and minimum.
the
Max minus
largest
mean.
minus the smallest value, you can say. Okay, that is my range, or you can say the maximum minus the minimum value. Okay, now this range is actually sensitive to,
Okay.
it is actually sensitive to outliers. Okay, then the second part is comes is variance. What do you mean by variance? Variance actually tell me the variability of the data set. How my data value, let's suppose if how my data value like is away from the mean. So I am actually calculating the distance of the data from their mean. So I am actually calculating the variability of the data set. Okay, so this is my variance. And what is the formula of variance? Variance is denoted by sigma square, which is summation of xi minus x bar whole square divided by n. So now here there are two things. If I'm talking about the population one, I will be dividing it by n. Or if I'm talking about sample, I will be dividing it by n minus 1. Yes or no?
Yes, ma'am.
Okay, so yeah, so these are my two formulas here. Now in this case also, if I add a constant here, then what will happen?
It won't be affected.
Nothing
It
changed.
won't be affected. So my old
Mm.
it will be equal to my old variance.
Oh,
Similarly, if I multiply a constant,
then it will be
C
changed.
square, C
it
square
will be c
into
square into the
Old
old
variance
variance.
into C square.
Correct, correct. Now there is another term which is known as the standard deviation. What is standard deviation?
root
The
under
root
of
of the
variance.
variance.
Yeah, it is actually my root of variance. Okay. So similarly, here also we have, it is denoted by sigma, which is under root of summation of xi minus x bar whole square divided by n or n minus 1. Okay. Similarly here, if I add a constant, if I add a constant,
No change.
no change, it will be equal to my old standard deviation only. And if I multiply a constant,
C into
So
old
old
this
variance
big.
into C.
mod of c into
Hmm.
old
Old
standard deviation.
standard deviation.
Correct? So that is my measure of dispersion. Then next topic
Ma'am, is it
comes
mod
as
of C?
mod of C. Yeah.
Okay, okay. If we are multiplying minus negative number, then the new standard deviation will be the
Yeah.
mod of
So see, if you see here, na, see, if I multiply, so if you look into here, this is C square into old variance, correct?
yes, ma'am.
If I have to calculate the standard deviation of this new one, so standard deviation of C square into the old variance will be equal to what? Square root of this whole thing.
Yes, ma'am.
So C square,
Yes,
this
ma'am.
so this will be what? C
Positive one
into the old standard
into
deviation.
old
So C
standard.
square, this will be a positive only, right?
Hmm.
That's fine. Okay.
Okay.
Yeah. Now we have the next topic, which is percentile. What is a percentile? Anyone?
So suppose we have NP percentile, then
Hmm.
like NP percentage of the data are
The thing
below
is,
me and
we are just dividing the whole thing into 100 percentile. Like there are 99 percentiles here till 99. So we are dividing a data into 99 parts. Okay. So each of the part is just telling me 1%, 1%, and 1%. Okay. So in this, what we say is we have like, let's suppose I'm saying 25th percentile. Okay. What do you mean by 25th percentile? That means 25% of the people are under me and 75% of the people are above me. So I'm at the 25th position. Is that thing clear?
Yes,
yes,
Okay.
ma'am.
And 50th percentile, what is a 50th percentile? It is actually denoting the
Median.
median.
ma'am.
Okay. And what do you
Middle.
mean by 75th percentile? It is actually telling me that 25% of the people are above me and 75% of the people are below me. Correct?
Yes, ma'am.
Okay. Now, what's the procedure to calculate a percentile?
It will be 2. If
The
NP
first
is
thing, the first procedure is we will
like if we
First we
arrange
calculate
first
in
the data.
then
yes
arrange in the ascending.
in ascending.
Yes or no?
Hmm.
Second point is we will calculate the value of NP. Okay. Now, after calculating the value of NP, there are two conditions. The first condition is if it is an integer. Okay. If it is an integer, then my percentile would be
NP
The,
and
the
NP
average
plus
of
1.
that
average of NP and NP plus 1. Okay. Now, if it is not an integer, then it will be only
the
uh,
next highest integer.
the next highest. Correct. Or you can say next highest. Next highest. value. If it's like 2.3, then we say that the third data, the third number is my percentile. Fine.
Yes,
Now,
ma'am.
we have one more thing which is known as quartile. What is a quartile? Quartile in the sense that we are dividing a data into four parts. So this three division is actually known as my quartile 1, quartile 2, and quartile 3. So quartile 1 is basically my 25th percentile, quartile 2 is my 50th percentile, and quartile 3 is my 75th percentile. So if they say that you have to calculate quartile 1, that means you have to calculate 25th percentile. If they're saying that you have to calculate quartile 3, they're saying to calculate the 75th percentile. Okay, the same thing, the same formula and everything. Okay, now the next thing that comes is IQR. Okay, what is IQR? IQR is basically the difference between quartile 3 minus quartile 1. That is my quartile, or you can say the interquartile range. Is that thing clear?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah. So that was all there in week 3. So week 3, we learned about how to describe a numerical data. So we have frequency table, we have stem and leaf diagram. So, and after that, we have some descriptive measures, which is like measure of central tendency. We have measure of dispersion. Okay, one more thing. In median, if we are calculating the median, what is the first step that you will be doing?
Arranging
Arranging in
in
the
Correct.
ascending
ascending
order.
order.
Always remember this.
Hmm.
Always remember this. If we are calculating the median, we will arrange the data first. Always remember this. Don't ever skip this top thing. Arrange the data. Similarly, if you are calculating for the
Percentile also.
percentile or the quartile, you have to first arrange the data and then you have to find out all the things. Is that thing clear? Will you
Yes, ma'am.
remember this thing?
Yes, ma'am.
Okay, always remember this thing. So this was all about in week 3 that you have to remember, or the concept that you have to remember in week 3. Okay, so most of the questions will they will be asking like the stem and leaf diagram have been given. Okay, stem and leaf diagram have been given. Now, according to the stem and leaf diagram, so you have to calculate the median, or you have to calculate the mode or the mean. So these type of questions can be asked. Okay, like the way, or you can say how to like they will be saying that calculate variance, or calculate the standard deviation and everything. Okay, simple questions.
Ma'am, outliers is left. That is
Sorry.
one
That
formula for
outliers, sir.
finding the outliers.
Okay, yeah. So outliers is basically there are. I guess we have not asked any questions on outliers, so you can just leave this topic actually. But I'll just write it down. So for the outliers, you will check the numbers which are less than quartile 1 minus 1.5 into IQR, and the data which are greater than quartile 3 plus 1.5 into IQR. First, calculate these two values, okay, and you will check the numbers which are getting. So this is my limit, okay. These are my limit. So the numbers which are getting less than this will be my lower, like the outliers, or greater than this will be my outliers. That's it. Okay.
Okay, ma'am.
Yeah. So that was all there in week 3. Week 3 is clear. You got the overview.
Yes, ma'am.
Okay. Let's go to week 4. Okay. So in week 4, we recently only did, so you guys already know what is there in week 4. What is there in week 4?
Firstly, the contingency table, the two-way
Association
table,
between
We are talking about the
categorical.
association between the
association.
variables. Okay, we are talking about the association. Okay, so the first thing comes is we are talking about the association between a categorical variable.
Categorical
So for a
variables.
categorical variable, what are the things that we do?
We make contingency table for
First thing
two-way
is we make a two-way contingency table. Correct?
Yes, ma'am.
table. Yes,
We make a two-way contingency table. Then the second thing is we calculate the relative frequency. Yes or no?
Yes, ma'am.
So in this relative frequency, we have two types of relative frequency. We have a row relative frequency and we have a column relative frequency. Okay. So what is the row relative frequency? It is actually what we are doing is we are dividing a cell of that particular row by their row total. Yes or no?
yes,
Similarly, the column will be that the cell of that particular column divided by that column total. Yes or no?
Yes, ma'am.
Okay. So if I have, let's suppose, give me a moment. Mm, So let's suppose if I have a number, if I have a table like this. So same example, I'm just going with the same example. We have female and we have a male. Okay. And the numbers are like 34, 10, 42, and 14. And the total here are like 76, 24. Then we have 44 and 56. Okay. Now the first thing is, if we are talking about the row relative frequency, we will be dividing it by. Okay, can you tell me for this cell?
34
Hmm?
44.
34
34
divided by?
divided by 34 is 1
Sorry?
They will divide that by 44 and multiply
Yeah, correct.
the whole thing with 100 for the percentage.
Yeah, so 34 by 44, 14 by 76, 76 by 100.
0.7.
Similarly, 10 by 44, 42 by 56 divided by 100, because this total is 100.
Ma'am,
Similarly,
but
if I'm
that
talking
column
about
relative,
column
that
relative frequency.
column total is, I think, incorrect.
Okay, so if I'm talking about column relative frequency, so this 34 will be divided by
76.
76. 14 will be divided by 76. 10 will be divided by 24. 42 will be divided by 24. This will be divided by 100, and this will be divided by 100.
Ma'am,
Is this thing clear?
42 will be
that
divided by
column,
24 will get a whole number, right?
ma'am, that column
mean,
total
more
is
than one.
incorrect, I think.
Yes, that has to
34
be
and 42 will give 76, and 10 and 14 will give 24. Like
10 plus 42 will be 52.
I said, if ma'am did 34 and 42, then it will give 76.
Correct.
34. Oh, okay, okay.
34 plus
Yes,
14
ma'am.
equals
Like this, now. Okay. Yeah. So, thank you for correcting me. But yeah, I want to know that you got to know what is a column relative frequency and a row relative frequency. Clear?
Yes,
Yes,
ma'am.
Now,
ma'am.
after calculating
Can you
this,
explain again row relative?
sorry,
Can you explain again row relative? How to find row relative?
row relative frequency is just what you want to do is you're going to divide a cell into with their row total. So if you see here, my row total is for this row. What is my row total? It is 44. So I will be dividing this 34 divided by 44. Okay. So this is how you calculate the row relative frequency. Okay. Yeah. Okay, now we have calculated the row relative frequency. Then the next step is we are going to study, like after the calculating, we have to study the association. So how from the numbers we are going to study about the association. So there are two rules. The first thing is, if my row relative frequency is same for all rows, okay, or if I say that my column relative frequency is same for all columns, then I say that there is no association, correct? Yes or no?
Yes, ma'am.
Yeah. And the next property is, if my row relative frequency is different for some rows, okay, or it is different for some columns, then I say that what I say?
There is an association between
There is an
Association.
association. Correct? Yes or no?
Yes.
none.
Yes or no?
Yes, ma'am. It's clear.
Is this thing clear?
Yes, ma'am. It's clear.
Yeah, okay. Now the fourth thing is, we can find the association or the condition between the two variables through numeric as well, numerically. But how will I do graphically? With the help of stack bar chart.
Stack bar chart.
Okay. or you can say 100% stack bar chart. So 100% stack bar chart, what is a 100% stack bar chart? We are not actually considering the count, we are actually considering the proportion. Okay,
Proportions.
so if this is female, if this is male, okay, so let's suppose if I'm stacking it, so this is like the percentage of people who are owning a smartphone, and this is the percentage of male people who are owning a smartphone. Okay, and the down thing, this part is actually the people who are not owning a smartphone. So if you see here from the graph also, we can study whether there is an association or not. Okay, so from this we say that there is no association between the two variables. If there was some association, so we would be having a graph like this. So okay, so let's suppose we are actually talking about the income level. Okay, so for the income level we have some like if we have low income level, then this will be like owning a smartphone. For the medium level, this is my owning a smartphone. If in the high level, this is my owning a smartphone. Okay, and the rest of this part, the down part, is like not owning a smartphone, not owning a smartphone, and not owning a fax. This is for the low income people, medium income level, and high income. So from this topic, from this graph also, we see that there is an association, because there is a difference where we see a pattern here. So if we see a pattern in the graph, we say that there is an association between the two variables. Is that thing clear
Yes, ma'am.
from the graph? Okay. So this was all about the categorical variables. Okay. Now the second thing that comes is the numerical variables.
Ma'am,
Okay. Yes.
can you explain normal stacked bar chart?
What? What?
A stacked bar chart, ma'am. How to interpret that?
This is only a stack bar chart. Stack bar chart is just a simple bar
It's a
chart.
100. Yes,
Yeah,
ma'am.
this is
It's a 100%.
100%.
I want that normal, that countable. We have some female and male in same bar like that, ma'am. Little bit difficult to interpret.
So this
Yeah,
is
like that,
female,
ma'am.
this is male. Okay. So we are actually taking the count here. So after taking the count, we are just segregating this, stacking the bar. This is like owning a smartphone.
Dividing in
This is also like
segments.
owning a smartphone. And this is not owning a smartphone. So, but here from this side, we are not able to like considering, because the main thing is we are having counts here. So the size of the bar is also different here. So we can't study it properly. So that's why we consider this 100% stack bar chart, because we are not at all considering the count. We are not at all interfering the count. We are just, the importance is the proportion. Okay. So that's why 100% stack bar chart is the most useful chart to study the association between the two variables. Okay.
Clear, ma'am. Thank you.
Yeah. Then we have the numerical variable. So for the numerical variable, the first thing is graphically, if you have to study, it is with the help of scatter plot. Correct? What is a
Yes.
scatter plot? It is actually including my x-axis and y-axis. X-axis is basically my explanatory variable.
Explanatory.
Okay. And my y-axis is basically my response variable.
Responsible.
Okay, and here are like the values 1, 2, 3, 4 or something. Here are like 10, 20, 30 something. So scatter plot is basically we are just pointing out the data values. Okay, so this is like 1 comma 10, this is like 2 comma 20, something kind of like. So we are just scaling, or you can say drawing the 2 points here. So this is my scatter plot. So from this scatter plot, okay, so if we have a scatter plot like this, how we are going to study it? So the first thing that you have to, like, how to describe the scatter plot, the first thing that you have to consider is the direction here. Okay, direction in the sense that if it's going upward, okay, or if it going downward. Okay, then the second thing that you will check is for the curvature. Curvature in the sense, if my scatter plot is like going straight, or if my scatter plot is going like in a curve form. Okay, then the third thing is you will check for is the variation. Okay, variation in the sense that if my data values are closer to each other, so this is one graph, And the second thing is, if there is a variability in the data set, that means all my data values are varying each other. Okay. And the fourth thing is, we will check for the outliers. Outliers in the sense that if we have a data set like this, let's suppose, and some of the few points, if you see here, one is point is here, one is here, one is here. So these all are my outliers. So these are the four things that you will check, or this is how you're going to describe a scatter plot. Is that thing clear?
Yes.
Yeah. Then the second thing that comes, so this is like graphically we're describing it. So numerically, how will we do it? With the help of covariance. Okay, so the first thing that you're going to describe an association numerically is with the help of covariance. So covariance is basically what? It is telling me the strength of the linear association between the two variables, correct?
Yes, ma'am.
Am I going too fast?
No, ma'am.
No,
No.
ma'am, it is okay.
No, it's fine, right?
Yes.
Because you guys have
Fine.
already done. That's why I'm just going a little bit fast.
Yes.
Okay. So it is actually telling me about the strength of the linear association between two variables. Okay. And the formula is basically covariance of between x comma y. It is summation of xi minus x bar, x bar yi minus y bar divided by. So if you are talking about population, it will be n, or it will be n minus 1 if you are talking about sample. Okay.
Okay, ma'am.
Yes.
Yeah. Okay.
Yes.
So if the first thing is, if my covariance between x comma y is positive, then the two variables will be having the same direction. Yes.
Yes.
Yes, ma'am.
That means if my x is increasing, my y will increase. If my x is decreasing, my y will also decrease. Then the second point is, if my covariance is negative, then I say that they are going in opposite direction. Okay, that means if my x values are increasing, my y values will decrease. If my x is decreasing, my y will increase. So this is what we have to consider in covariance. Now the main thing is, in covariance, x is a two. There are we are considering two variables, right? So this will be having some one unit, and this will be having some other unit. Correct. So we actually, so if we are calculating this covariance, the answer will be in two terms, two units, right? One unit for the first unit of x and the second unit of y. So that will be not a valid number. So that's why we have a third thing, which is known as the correlation.
Correlation.
So that the number that we are calculating, or the number by which we are quantifying that strength, is valid. So that's why we have calculating correlation, which is represented by R, which is the covariance of x comma y divided by the standard deviation of x into standard deviation of y. Okay, or you can say summation of xi minus x bar yi minus y bar divided by under root of summation of xi minus x bar whole square into under root of summation of yi minus y bar square. Okay. Now here my what is the range of correlation? It is going from -1 to
Minus
1.
1 to
That
1.
means correct. That means if my it is closer to 1, we say it is a strong positive correlated. If it is closer to -1, we say it is strongly negatively correlated. Okay.
And if it is 0, ma'am, then
No correlation.
okay.
Okay. Now this was all about the correlation. We have covariance. Then the last thing that comes up is, if my two variables, like if one variable is numerical and the other variable is categorical, then we calculate what? Point by serial
Point by serial.
correlation coefficient. Okay. So the formula is basically, it is represented by RPB, which is mod of x bar naught minus x bar 1 divided by standard deviation of x into under root of p naught into p1. Okay. So x bar naught is basically, it is the average of the people who are there. So like, let's suppose if my 0 is denoting the number of people who are failing. So average of the people who failed. Okay, x bar 1 will be what? The average of the people who pass the exam. Okay, so here my 0 is denoting fail and my 1 is denoting pass. So like it is, I am actually denoting this 0 and 1. So this 0 is actually 0 and 1 is categorical variable. So this 0 is actually representing something and 1 is representing something. Okay. So it is not always fail and pass. It can be anything. Okay. Then here we have standard deviation of x, which is the standard deviation of that x numerical variable. P naught is basically the proportion of people. We are talking about the proportion of people who fail. Okay. And P1 is basically the proportion of people who pass. Okay. So after calculating all these values, just put all these value into this formula. So you will get my point biserial correlation coefficient. So this is only when we have one numerical and one categorical variable. Is this thing clear?
Yes,
Yes, ma'am.
ma'am.
Yeah.
And that
So
should
this
be
was,
population standard deviation, right?
yeah, this should be
Hmm.
population standard deviation. Correct. Very good.
Okay.
This should be population standard deviation. Okay, so this was all about in week 4. So we are talking about the association. So if we have categorical, we go with the row relative or column relative frequency. If you have numerical, we go with scatter plot, covariance, and correlation. And if we have one numeric and categorical, we go by point biserial correlation coefficient. So I guess week 3 and week 4 is all clear. Yes or no?
Yes, ma'am.
Yeah.
I have a doubt. Ma'am, can you just explain the last thing that was point biserial with an example?
Sorry, sorry.
Ma'am, can you explain that last point biserial with an example with a very small data set, if possible?
With an example.
Yes, ma'am.
Real life example, ma'am. Yes, ma'am.
Real life. 1 second. I've already done it now. See, if you see here, we have this data. We have the scores. We have the group. So here my 1 is representing the people who have passed. 0 is representing fail. Okay. So now the formula is x bar naught minus x bar 1 divided by standard deviation of x under root p naught into p1. Okay. So now here x bar naught is the average because 0 is denoting fail people, right? So I will be, so x bar is basically denoting the average. Average of what? Average of the people who have failed. So if you see here, how many of them have failed? This many people have failed, like this 1 and 2. So their average score was 4 and 5. So I will be calculating the average of 4 and 5. Similarly, x bar 1 is the average of the people who have passed. So how many of them are passed? These 3 people have passed. So I will take the average of these. Then standard deviation of x, I will be taking the standard deviation of this whole value. Then P naught is the proportion of students who have failed. So in out of 5, how many people have failed? Only 2 of them have failed, right? So it will be 2 by 5. Similarly, P1 is proportion of students who have passed. So it will be out of 5, how many of them have passed the exam? It will be 3 of them. So
3 by
that's why
5.
that is 3 by 5. So put all the values in the formula and you will get some value. That's it. Clear?
So clear.
Yeah.
Yes, ma'am. Clear.
Okay. So this was all about week 3 and week 4. Okay, now you guys, can you guys get pen and paper because we are going to start solving some questions. So I need you to guys solve the question and tell me the answer. Okay, so you guys first bring a pen and paper and let me know whether you are ready with it.
Hello, ma'am.
Yes.
Can you just explain the fitting a line with an example that y is equal to mx plus c, that concept?
That fitting of line is actually not in the, like it's not coming in the exam, so you don't you can leave that topic if it's uh, uh, that will
Oh,
be fine. You don't have to.
okay.
Are you guys ready with the pen and paper?
Yes, ma'am. Yes,
Okay,
ma'am.
Yes.
let's start with the first question. So the first question is the number of awards given to a university drama club each year for outstanding performance is represented in the following stem and leaf plot. So if you see here, if you look here, we have the stem and leaf. And they're also telling us that my 3/8 is representing 38. So that means my 2/0 will be representing 20. 2/3 will be representing 23. So they have already stated it. Now, the first question is, what is the mean number of awards given to the drama club if each observation is multiplied by 2 after adding 3 to it? So I need the answers for the first and the second. You guys solve it and tell me the answers.
I'm 76 and 72 by 2, that is 36.
76 and 36. Okay. What about others?
So ma'am, mean is 393.
Yeah, 73. Hello.
73. Okay. Okay, so for this is one person is getting 76, the other person is getting 73. This is 36. Any other answers?
73.
Yes, ma'am,
73.
73.
Okay, so 2 votes for this. Then
26 is the median for this.
sorry,
26 is the median.
36 is the median. Okay. So everybody median the answer everybody is getting 36, huh?
Yes.
So I got only 3 answers. 1, 2, 3.
36. Median would be 36.
Yeah, okay. So in short,
76,
like I got
36.
3, 4 answers from 3, 4 people. What about others?
Mean
How many
is
people are there?
76 and median is
Yes,
36.
ma'am.
Ma'am, your screen
It
is not
is,
visible.
ma'am,
Your screen is not visible.
the mean is 73. 73 and the median is 36.
Okay. So like there are 3, 4 votes for this. Then that's it.
Mean is 73 and median is 36.
Okay.
Yes, ma'am. Mean is 73 and median is 36.
Yes, ma'am. It's that.
Yeah, ma'am, I guess 76 will be the answer because we are first adding 3, then multiplying by 2.
Let's see. I have not solved it. After solving it, then only I will get to know. Okay, so should I solve it or should I wait for more students to complete it? Should I solve it? I'm not getting any answers also. So
Yeah,
can I solve? Okay.
yeah.
So the first question is, what is the mean number of awards given to the drama club if each observation is multiplied by 2 after adding 3 to it? So we are calculating actually mean. So what is my data here? 20, 23, 26, 32, 34, 38, 40, 42, 43, and 52. Okay. So how many data set do I have? I have 10. In total, I have 10. So the first I will just actually calculate my mean. Okay, the actual mean. So my actual mean is basically adding all these value divided by 10. Okay, can you guys add this value? What is the value that you're
350.
getting? Okay, so
350
this is
divided by 10.
350 divided by 10,
350
which is
by
actually
10,
35. So my
35.
actual mean, this is my actual mean. My actual mean is coming out to be 35. Now the condition is if each observation is multiplied by 2 after adding 3. So first what we will want to do is we will add 3 and then multiplied by 2. So this will be 35 plus 3.
38 into
38.
76.
38 into 2, which is 76. So my mean will be equal to 76. So the answer is 76, not 73. Is this thing clear?
Yes.
How
Yeah.
did it happen? Will you please
Yes,
explain?
ma'am.
Sorry?
How did it happen? Can you explain one more time?
See, what they are saying in the question is they are saying that each observation is being multiplied by 2 after adding 3. So first we will add 3 and then we will multiply it by 2, no?
So each observation is multiplied by 2 after adding 3.
After adding 3, we are multiplying it by 2.
Okay.
Okay. Now the second is we have to calculate what is the median of the data set. So in total we have 10. That means we have even number of observations. So if we have even number of observation, then it will be what? The average of n by 2 and n by 2 plus 1, right? So that means average of fifth observation plus the sixth observation divided by 2, which is what is the fifth observation here?
34 and 38.
34 and 38.
One
Fifth observation
34 plus 38 divided by 2, which is 30.
72 by
36.
36. Yes.
Okay. So I am going to ask you something. Like if I'm calculating this median, I have not even arranged this data. Do I have to arrange the data?
No, because it
Because
is
it
in
is
Stem
already
leaf plot is
stem leaf.
already arranged.
correct. Correct. Okay. So is this question clear to everyone?
Yes, ma'am.
Yeah. No doubts?
Mm.
Okay. Let's proceed with the next question. Okay. A study was conducted to investigate the association between smoking habits and lung disease. What proportion of smokers do not have lung disease? Calculate the value and tell me the answer.
Is it going to be 60?
0.6, ma'am.
Sorry?
60%?
0.60.
0.60.
They're asking proportion.
Yeah. Then it will be 0.6.
Okay, 0.6. Any other answer?
Zero 0.6, ma'am.
0.69. Okay.
6, 9, no, ma'am. 6, only 6.
So I got 3 votes. 2
0.6.
people answer. Sorry?
Yes, ma'am. 0.6.
2.6, sir.
0.6.
Okay, 4. Okay. So 6 people got the answer. Then what about the others? There are 20 people here. I'm hearing only 6, 7 people. What are the other guys doing?
0.6, ma'am.
Okay. Hey, if everyone is speaking, then only the session will be more interesting, right? Only 7 and people, the same people will be talking, then it won't be good. Like, because they are doing it, I know they are doing it. What about the other people? At least speak up. I'm not going to, give you any punishment or something if you're saying wrong or something. It's an online class. You can speak up. Relax and speak up. Okay. So I got the 7 or 8 people. I got answers from 8, 9 people. So should I wait for the other people or should I solve it?
Yes,
What
ma'am.
should I do?
60% 0.6 is
0.6.
the
Okay.
Proportion is also.
Okay. So I guess everybody is getting that answer. So maybe that is my answer. Okay. Let's check. So they're asking what proportion of smokers, they're talking about smokers who do not have lung disease. So we are talking about the proportion. So the first thing is we need to know the value of Z. Correct. So to
Yes.
find the value of Z, we can actually, what we can do is we can just minus it, right? From
Yes, ma'am. 300
okay.
minus
So my
200
Z
can
will
be
be equal to 300 minus 200, which is equal to 100. So
100.
in total, the number of smokers I have is 100. Now, the smokers who do not have, so proportion of smokers who do not have lung disease is basically, how will I calculate the proportion here? It
Row
will be,
relative
Row relative
frequency.
frequency.
it will be row relative. That means my X divided by 100, correct? So the now here, what is my X? I don't have my X. So I have to calculate the X value as well. What will be my X here?
100 minus 40.
So my X
60.
will be
60.
100 minus 40, which will be 60.
60.
So this is 60 by 100, which is 0.6.
0.6.
So my answer is 0.6. Fine,
Yes.
everyone?
Yes.
Yes, ma'am.
Can we move towards the next question?
Yes.
Yes, next.
Okay, good. Solve this question and tell me the answer.
Ma'am, option A and option D.
Option A and option D. Okay.
Yes, ma'am. Option A and option D.
I think option D.
Ma'am, can you show the
Yeah,
question
D.
again?
Ma'am,
Only
option,
option D. Option 1 is incorrect, I think.
ma'am, option A and D.
So I've got two votes here. Then
Option D. Only option D.
Yes, ma'am.
okay.
Only option D.
Okay,
Yeah, D.
that's it.
Option A and D. On my side.
Okay, so three votes. That's it. I got only five people, like five people only answered. Five, six people only answered. What about the others? Still solving?
Solving.
Okay, solve.
Hello, ma'am.
Yes.
Ma'am, I just have a doubt related to this association. Can I ask that now or after this question?
Association. Okay, what's your doubt?
Ma'am, actually, my doubt is so while finding the association between these two variables, so we are considering the similarity of row relative frequency, right? So suppose all the rows are giving similar relative frequency, right? Suppose one is giving 64. Let's say in this case, this row 1 is giving 64, row 2 is giving 65, and row 3 is giving 66. Then is like will that be considered as similar so that there is no association?
Yeah, like they're in the same range only, na 60,
Okay.
65, like.
So what could be the range, like approximate range, the difference?
The thing is, it should not be that much. Like the pattern should be like, if it's like total percentage, the total percentage, the pattern that it's following is like 74 and 73. So all the other rows should so follow that, like maybe 76 and 72, something kind of like that. So it should be. See, we are just comparing. We are just like from the total. Okay, I will just explain
Yes,
it in this example. Okay.
yes, ma'am. Okay.
Okay. So I got only 4, 5 people, 6, 7 people answers. What about the others still solving?
A and D, ma'am.
A and D. Okay. 4 people answered.
Ma'am, A and D.
A and C, ma'am.
A and C. Okay.
It's D. Only D.
I
Only D.
wanted to ask that if difference of like
What?
point, I wanted to ask that if difference of 0.15 is there, then we can say that they are somewhat similar.
0.1 difference. Difference. See, we don't see the difference. We see just the pattern. Okay, let's solve this question. Okay. So should I solve it, or still people are solving the question? Should I solve it?
Yes,
Okay.
ma'am.
So what is
Please.
the first question? The first question is, more than 65% of the individual are willing to buy the new model of sports car. Okay. So first of all, what the question is, willing to buy less than 18, age group 19 to 30, more than 30. Okay. So this total is basically what? 40 plus 54 plus 86. This is 180 and this is like 80. Correct. This is like 60. This is like 54 and 36, 90.
90.
86 and 24. 86 and 24. 1010 now. 110. Okay. So this will be this. So the first thing is, more than 65 are willing to buy the new model of the sports car. Willing to buy the new model. So this will be what? So first option will be like 180 divided by the total.
260.
Which is
260.
260. This is coming out to be like
Approximate 69.23.
Yes.
okay,
Approximately 69%,
69.23%.
which is
Right.
more than 65.
Yeah,
More
so
than
this is coming out
65
to be
of
greater than
individual.
65%. So we say that A option is correct.
Yes.
Now, the second option, approximately 35% in the age group 19 are not willing to buy the new model of the sports car. So that means so we are calculating the percentage from 19 to 30. Okay. So from 19, it's 90 are not willing to buy. So that means it will be, the proportion will be 36 divided by 90. Correct. So this
Yes.
will be what? 36 divided by 90, which is like 0.4, which is 40%. So they are saying 35%. So this option is wrong. Then we need to calculate the association. Okay. So the first thing is 40. So what we have 40, 54, then 86, 20, 36, 20, 36, and 24. Okay. Then the total is 60, 90, 100, 10, 60, 90, 110. And the total here is 86, 180 and 80. This is 180 and 80. And the total is 260. Okay. So this is my total. So now we will calculate, let's see the row relative frequency here. So the first thing is we will calculate what is 180 divided by 260. It is actually 69.23, right? So 69.23%. Similarly, 80 divided by 260.
Ma'am, actually, you don't need to calculate that. We can just calculate the upper one.
Which part?
This 86 divided by 110.
30.76.
Ma'am, I'm saying that we don't need to calculate that. We can just calculate the upper row value, that is 86 by 110. From that
Yeah,
only
but
we can get the
from here,
answer.
but we need to know now what pattern they are following. So in total, the people who are like willing to buy are like 69% and who are not willing to buy 30. So this is my pattern. So now I will check for each of the rows that if they are having the same pattern, if they're following the same pattern. Okay. So this will be, so here 40 by 60, it will be like 66%, 0.66, like, okay, fine. Then like 20 divided by 60, it will be like
33%.
33%.
33%.
54 divided by 90, it will be like
60%.
60%.
60%.
Then 36
40%.
divided by
40%.
40%. Then we have 86
0.78,
divided by 110,
78%.
78%.
21.
And 24 divided by 110,
22%.
21%. So if you see here, we have a difference here, right? Difference in the pattern, 78%, 21%, 60% and 40%. Correct, but this one is fine. But these both are having a different pattern. So we say that there is an association between the two
Yes.
values. So my options, the correct options
A
are
and
my
D.
A and D. Fine?
Yes.
Yes, ma'am.
Okay. Now the fourth
In
question.
this, even
Sorry?
ma'am, one doubt, ma'am. Ma'am, in this
Yes.
row level frequency, even one row show the difference means it will, there is an association we should think.
Correct.
Okay, ma'am. Thank you.
Now, next question is, suppose the three variables x, y, z are measured. It is known that rxy equals to 0 and ryz is 0, where RAB denotes the Pearson correlation coefficient between variables a and b. Which of the following statement is or are true?
X and Y are independent. Ma'am, I think option number A. X and Y are independent.
That's it.
A and D, zero correlation between two variables only means no relation.
Something A and D, A, and then any other options?
Ma'am, A and D.
A and D. Okay, we have got two votes here for A and D. Then
B and D. ma'am.
B. Oh, B and D. Then any other options? B and D, A and D, A, C is remaining. X and Y are independent, X and Z are uncorrelated. The correlation between X and Z may still be non-zero. Zero correlation between no linear between them. Okay. So should I wait for more replies or should I solve it? What should I do?
Yeah, we can solve
Please
this.
solve it.
Okay. So the question is, we have three variables here, which is x, y, and z. Okay, and we have given us the relation. That means rxy is 0. Rxy means the relationship, the correlation between x and y is 0. That means they are uncorrelated. And we have y and z. It is telling me that the correlation between y and z is being uncorrelated. Okay. Now, what are the options that we see here? The options are x and y are independent. Okay. So now here we have that x and y is 0. That does not mean, see, they are uncorrelated. Okay. But that does not mean that they are independent. It is not necessary. Okay. So always remember that if my, let's suppose if my correlation is coming out to be 0, it is showing that it is uncorrelated. Okay. But it does not imply that they are independent. Okay. This is like one important condition. Always remember this thing. Okay. But we can say that if something is independent,
And what is the
independent
meaning of independent?
independent in the sense like the one variable is not being defined by the other variable. So that is what do you mean by independency? Okay. So that is what independency is. So we can't say that uncorrelation means it is like uncorrelated, like there is no like in the sense like I can study about that my if my values of x is increasing, my values of y is decreasing. Like I can study about the strength and the association, but I can't say anything about the dependency or the independency. How is my one variable is being dependent on the other variable? Okay, so this is one point, that if they're uncorrelated, if my correlation is coming out to be 0 between the two variables, that does not imply that they are independent. But if I say that one thing is, if the two variables are my independent, I can always say that, I can always say that they are uncorrelated as well.
So
Okay.
that would be non-linear correlation, right?
Linear correlation. Okay, so that's why my A option is wrong, and X and Z are uncorrelated. We can't say because they have not said anything, any relation between X and Z, because only X, Y, and Y, Z relation have been shared. So this also is wrong. The correlation between X and Z may still be non-zero. So it can be non-zero, it can be a zero. So it can be like they are saying may. Okay, so that why C option is correct. Then D option is zero correlation between two variable only means no linear relationship between them. So that's why what zero means. So correlation is what we are studying about, the linear association between the two variables. Correct. So if it is zero, that means there is no linear
No linear
relationship between
relationship. Yes.
them. So that's why C and D options are correct.
Correct.
Is that thing clear?
Yes.
Please explain B option again. Why X and Z are not correlated?
Are you seeing any? Can you just tell me where it is given that X and Z is zero? That R X and Z is zero. Can you just show me this thing?
No.
Yeah. So that's why we can't say that they are uncorrelated.
Ma'am,
So-
uncorrelated
Kind
means
of tricky
correlation
question.
is 0, right?
Correct.
Okay, so like I'm still confused in this independent, dependent things. I mean, so like generally we do this correlation in two variables, right? We are considering in bivariate data sets, just like X and Y or Y and Z. So here the question is in three variables. So I mean, I can
But we are
understand, but
only talking about X and Y, na? Here we are just talking about
um,
X and Y. We are not talking about X, Y, Z. We are just talking
okay.
about X and Y.
So the correlation between X and Y is zero, exactly
Correct.
zero. That means,
Correct.
can we say that one of the variable having all the value as same?
Huh?
If the correlation uh, between if the correlation is zero, then can we say
Hmm.
that one of the variable have the same data values? Let's
No,
say 3, 3, 3, 3, just like that.
that's not necessary.
Okay. Is there any
Like
other
it's like
case where
it is not necessary that every time the data value will be same. We can have different data values as well. It's just that the see, when is my correlation is coming out to be zero? When my covariance is coming out to be zero. That is summation of xi
exactly.
minus
Okay.
x bar. Huh. So that is what. So that's when my correlation is coming out to be zero.
Okay. Okay. Okay,
Okay.
ma'am.
Mhm.
Okay.
Can we move on to the next question?
Yes.
Now, a government agency aims to evaluate the cleanliness standards of hospitals in a specific district of Uttar Pradesh. To do this, they randomly selected 20 hospitals and assigned each a cleanliness rating on a scale from 1 to 5. Oh, this is from week 1 and 2. Okay. Based on this scenario, which of the following statement is or are correct?
Option number C.
Okay. Sorry?
C and D.
C and D.
Yes, ma'am. C and D.
Okay.
C and D.
C and B.
C and D. D.
Yes,
Okay.
ma'am.
Okay.
It is also
Third
correct.
and fourth option.
A
Okay.
and
C
D.
and D.
Yes, ma'am. C and D from my side.
Okay. Any other? So everybody is getting this answer C and D, correct?
Yes.
It's just simple. So we have
Yes,
ratings.
ma'am.
So based on the scenario, which of the following? The sample consists of all the hospitals in the district? No. The cleanliness rating are measured on nominal scale? No. This is an
No.
ordinal scale. The
Ordinal.
population is all the hospital? Correct. If the agency concludes that the cleanliness is good, this would be an example of inferential, correct?
Yes, ma'am.
Okay. Now the last question. Let X and Y represent the total marks of Mayur and Deepak in 5 subjects respectively. If the marks scored by Deepak is twice the marks scored by Mayur in each subject, then which of the following statement is correct?
Option C.
Option C.
Option number C.
Okay. Any other
Option
options?
C.
Okay.
Option C.
Okay. That's it. Any other answers?
C.
C.
There's strong positive correlation between X and Y.
Any other
Yes,
answers?
ma'am. C.
Okay. So basically what they are saying that so X is representing the scores of Mayur and my Y is representing the scores of Deepak, right? X is the score of this and Deepak. So they are saying that the Deepak's marks is twice the marks of Mayur. So it's basically a linear relationship, right? So if we have a linear relationship, we say there is a strong positive correlation between X and Y. So that is option C is the
Yes,
correct
ma'am.
one. That's it. Okay, so this was my last question. That's it for today's session. Okay, so that was all. So I have you guys learned about week 3 and week 4? Is the topics clear? Everything is clear?
Yes, ma'am.
Yeah, it
Yes,
was
ma'am.
easy. The questions were
Mm.
easy. So normally what type of questions will come? They would like these type of questions, or they're gonna ask you about the population covariance, or they're gonna ask you simple what is a, or you can just or what do you say, calculate the population correlation or population covariance or sample covariance, or they're going to ask you about the association, this kind of questions and all. So yeah, these type of questions they will be asking. Calculate the standard
Okay.
deviation or variance, that's it, formula based. or
Yes, ma'am.
maybe
It
this
can be
concept
either
wise.
theoretical or
Ha.
that
So like
numerical
concept wise
also.
as well. Correct. Okay. So that's it. So the questions that you solved it right now, it was simple, right? Not that difficult. Correct?
Yes, ma'am. That-
Yeah. So that's what. So you have to read the question carefully and do the answer, do the solution. That's it. Just
Yes.
relax and read the question. Okay. So that was it for today's session. Anything else?
Yeah, no, one question. We have not yet started the fifth week content, and I believe tomorrow they will release this sixth week content, right?
Yeah.
So it would be very hectic after quiz to complete 2 week assignments and read the whole content.
The DA sessions were there of week 5,
So
in
week
which
5, the
week 5
deadline
were
is on
discussed.
Friday, na? Next week. After the quiz
No,
only the deadline is there.
Content, right?
Yeah, on Friday is the
TA
deadline.
sessions were also there.
How is the TA session going on, guys?
It's good.
It's going good?
Good.
Yeah, I have.
Yes, ma'am.
Yeah.
You guys know the TA's name? The two TAs?
Yes, ma'am.
Yes?
Uday sir and
Shreyank sir and Uday.
Priyank sir.
Okay, so how are they both? How is Shreyank? How is he doing?
Yes, ma'am. They're explaining nice.
Okay.
Sorry?
They both are explaining good.
They both are explaining good.
Hmm.
So nobody is going too fast or too slow? Nothing? No issues?
No, ma'am. No.
Everything good?
Yes, ma'am. In detail, they are explaining.
Okay, then that's good. That's perfect. Okay.
Ma'am, shall we get any bonus mark from graded assignments?
No bonus mark is just that like there will be one exact question that will be coming from the graded assignment from any of the week from week 1 to 4.
And what is
Ma'am, the
Okay,
extra
ma'am,
activity?
actually, I was asking about the final grade. In our final grade, shall we be getting any bonus marks from?
Yeah, that will be like after the end term and all.
Okay, so we'll be
will be
getting based
from
on what things? Graded
it will be
assignment or
based
mock
on
tests?
extra
No, it will be
activity,
based
I think
upon
so.
the practice assignment or the mock test that you're doing or anything that like how much you're contributing to the course, like how much you're doing it.
Okay, ma'am.
Yeah, so we
I
are
think
just
that
checking.
extra activities will be released.
Ha,
I think
extra
that would contribute to.
the extra activity will be given if you pass the exam.
Hmm.
After
Okay.
passing the exam, then only we will add the extra activity marks as a bonus.
Ma'am, can I get the student handbook link here? Like if
I think it's
anyone
in the
have
portal
this.
only.
Okay. In
Yeah,
portal?
it's in the portal. Yeah.
Week 0.
Thank you. So
Okay,
yeah,
ma'am.
that's
Thank you
it.
so much.
Okay,
Okay,
thank
ma'am.
you everyone.
Thank you
All
very
the best
much.
for the quiz one. Okay, just relax and give the exam. Okay,
Thank you.
study well. Yeah. Okay,
Thank
bye
you.
then. Have a great night. Good night, everyone.
Good night, ma'am.
Good night.
Good night, ma'am.
Good night. Good night.
Hello? Hello? Why is everyone silent? Please, anyone, please tell me. Because I joined it, so hello. Right, ma'am? Okay, okay.